Chemistry bands. Okay, so here we go. We've got homework assignment unit 6, and I believe this is topic number 2 finally. So let's jump right into it. We are going to figure out the shapes of some molecules. So we've got to go over here, and what we are trying to accomplish now is how in the world do we draw these Lewis structures and then determine their shapes. We learned that there are 5 different shapes last time. We're going to try and assign one to each of these 2 problems here and then differentiate betwixt the 2. All right, so I've got NH3. The first element always goes in the middle. Then I'm going to do want minus have on this one to determine how many bonds there are. Now, reality is we don't need that because hydrogens, we should know at this point, always have single bonds. But I'm going to do want minus have just to prove my point to you. So I've got 8 for the nitrogen, and then I have 2 for each of the hydrogens. So I've got a total here of 14. My halves is 5 valence electrons for the nitrogen and 1 for each of the hydrogens. That makes a total of 8. The difference between those 2 numbers is 6. So that means if I divide it by 2, I have 3 bonds. Okay, so single bond for each of the hydrogens as predicted. And then because I have a total of 8, I actually have 2 left over, but that's good because the nitrogen needed 2 more so that it would have a stable octet. Okay, now what this means is that these 2 extra electrons are going to push on these bonds. They're going to cause repulsion, and that is going to cause it to bend downward. So what we have actually is a trigonal pyramidal shape. All right, now I'm going to do the second one, and I've got C in the middle, I've got H's on the side, and I have an O on top. So it looks very similar to the NH3 one we just did. Let's go ahead and do the math associated with this one, want minus have, because now this time we do not have all H's, so I can't assume correctly what is going to be the difference betwixt them. All right, so I have 4 elements, but only 2 of them want 8. So I've got 8 plus 8 for the carbon and the oxygen, and then I have 2 plus 2 for the 2 hydrogens. That's a total of 20. The halves, 4 for the carbon, 6 for the oxygen, and 1 for the 2 hydrogens. That's 12. The difference is 8 divided by 2 means that I have 4 in the bonds. So I know that there's going to be single bonds for the hydrogen, and what this means is there's going to be a double bond for the oxygen because I have to have 4 bonds. Now I have 12 total electrons, so I can go ahead and fill in the extra electrons on the oxygen. There is no need for extra electrons on the carbon. It already has 8, and the hydrogens only want 2, so they don't need any extra. So that's how I know that I've got this structure correct. Now, what I notice is there are no extra electrons causing repulsion. This molecule will lay flat as a triangle. So this one is called a trigonal planar. Trigonal planar. Now, to answer the question number 3, why do they have different shapes? It has everything to do with 2 factors. One, this molecule has extra electrons, a lone pair that is on the central atom, and this one has a double bond. If I have a double bond on the central atom, it's going to cause it to be a trigonal planar. If I have a lone pair of unshared electrons on the central atom, it's going to repel the molecule's other bonded electrons and cause it to have a trigonal pyramid shape. All right, this is everything that I wish to share with you. So thank you very kindly for your time, and I will talk with you again very, very soon.